this programme of British Motor Works, an awfully irate owner whose $200,000 Aston Martin DB9 V12 supercar blew up on him after only 9,000 miles at 30 miles per hour. He asked Barry to convert the factory rubbish engine into a bulletproof 600 plus horsepower animal.
Yes, I mean, as far as we're at the moment, we've got all the ancillaries off from the tunnel, and the transmission's all exposed, and the drivetrain. So once we've got that off, we're going to disconnect a lot of the engine loom itself. When we drop all the engine loom out, we've got a lot of the exhaust headers are coming down. It's all starting to actually come down now, so the progress is coming on a lot further. As far as like a lot of the actual parts they do, they're actually removable nicely. Things are easy accessible, things can come down quite nicely, and it's just a question of more and more stuff is coming off, and it's starting to progress quite nicely now. The problem, you can see the oil leaking through the actual exhaust headers themselves. Both sides are quite wet, where it's the oil has come from the engine, it's started to flow through the exhaust, obviously, as it shouldn't. Once we've removed obviously the air boxes, because we had excessive amounts of oil coming through the actual air filters. So we've removed them, and they were saturated. Once we realised that the actual throttle body itself was letting all the oil through, and the Blenheim chamber was leaking through to obviously the air filter, it was quite excessive. So this is when we started to take things further, remove the spark plugs, and obviously start to see obviously if there's any cylinder damage, which is quite excessive on cylinder 12 and cylinder 6. Which is obviously, that's the reason why we're trying to take the engine out now, because of the excess damage has been done to it. The shape of the actual piston, once we took the spark plugs out and we put the camera actually in through the piston, we went right through the head of the piston, and we could see the actual crank journal itself, where the conrod had actually torn away from the underneath of the piston itself. It had ripped the actual gudging pin and the skirt of the piston away. The piston itself is still actually seized inside the cylinder at the top by the head, which is what's damaged the spark plug and damaged the valves as well. So it's quite excessive, the damage to the engine. What caused that to happen? It's not a question of that, it's a question of what's actually happened engineering-wise. Engineering-wise, it's the piston is where there's oil starvation, where it's not getting the right amount of oil delivered to the cylinder. The piston has expanded and grabbed hold of the side of the cylinder, which in theory has seized it, and then ripped the gudging pin, and this conrod directly from the actual piston. It's torn it underneath, which obviously the size of the engine and the torque that's coming from the engine was just detached itself from the bottom bit. Where they've actually designed it, it's a manufacturer fault, because it's causing starvation to the rear of the actual engine. To actually do number 6 and number 12 piston to do exactly the same thing, when the oil level must have been at quite a good capacity to not put no oil light on inside the vehicle, then to actually seize the pistons up, it must be some sort of journal that is not got the right diameter to let the oil flow through it. I mean, as far as when with Aston Martin building the vehicle, I think they've done it in the aspect, obviously, to keep it as a performance car, which it is, a very performance car. And with it's all aluminium, it tends to make it a lot less tolerable for the actual time. Rather than getting excessive amount of miles out of it, I think you're looking at a low end more of the mileage. But when you're looking at 9,500 miles, it does seem a bit excessive for an engine rebuild at this moment in time. I mean, obviously after speaking to Aston Martin headquarters, the actual problem of the car, thinking that it would be like you'd get some sort of, well, we could do this, we could do that. It's not really. We expected more from them than obviously just saying we've never heard of this before. This is not a common fault. But I mean, realistically, speaking to other people and starting to look at other situations, this is quite a common fault. It is obviously an engineering design which is actually causing the problem, because oil starvation to actually the 2 rear pistons is obviously a manufacturer design. And this is what we can't understand. By ringing them up, I thought I'd obviously speak to the headquarters, thinking that we would get some sort of help, but other than like, I don't think we've ever heard of this before, doesn't really seem to be enough help. And that's obviously where we've got from them. No more was indicated. Couldn't deal with them, had to be an Aston Martin franchise. They wouldn't deal with us directly as being a registered garage, which is quite frustrating, being a mechanic. And this is how it's come to the stage now where we're going to rebuild it. If it's a question of the oil being low, why can't they have another gauge on the vehicle which would look nice, saying an oil pressure gauge rather than just an oil light. If you had an oil pressure gauge, you could see the poundage was low and obviously you'd know there's a problem, rather than an oil light coming on and now you've got a major problem. This seems to be a very bad design of fault, as well as the engine. If they feel that this is a problem, they should have been putting a gauge in there so you could obviously see what the actual problem was with the oil level itself. I mean, designing obviously the car to be a race car, which obviously it is, the way that the transmission designed and the engine to actually, the power to weight ratio and the balance of the actual transmission. You'd think the car itself, every race car that goes around every track is designed with an oil pressure gauge. If you had an oil pressure gauge on the vehicle, you could actually study the oil pressure for the actual continuation of driving the vehicle. With having a light, it's such a basic effect that has been moved on from the past years. I think earlier Aston Martins had gauges, why is not the DB9? This is the cylinder that's gone, the one at the rear here and the one at the rear there. Both cylinders, obviously the pistons have completely been detached from the conrods, and that's where the damage is actually lying, right at the back. Everything else is good, all the spark plugs are good. These two spark plugs are damaged where the piston has come up and smashed them. Now that we've got the car obviously raised above the engine and it's all on the floor, we can start to actually take some of the engine apart and actually find out what damage has been done internally to the engine itself. So if we start by removing we've loosened the bolts, and obviously we've taken all this apart already to obviously inspect what's actually happening. Then we come down to the front section. As you can see, the inside of the engine is absolutely spotless, no sludge build-up. Once we take this off, you can remove this head. We can see that obviously the rear cylinder this side is where the damage is appearing on this cylinder. And we remove that cylinder head, and obviously you can see the damage that's appeared in this cylinder. This is obviously the piston itself, which has just got sideways and just completely jammed in the actual cylinder itself. It's cracked in half and just lodged right in there. It's just impossible to come out as it is. As you can see, where obviously the damage has been done and the oil has actually gone through the engine, all the pistons are coated with a residue, which is oil that's obviously gone through the Blenheim chamber when the vehicle was running. And obviously this is obviously what has been done to it, where the oil was actually picked up and gone back through the engine, and where the oil starvation was at the two rear cylinders. This is obviously what's caused the engine to cause engine failure. And you can see the amount of excessive damage that's been done to it. And to do that sort of damage to two rear cylinders, it's got to be oil starvation and not the correct amount of oil delivery to the rear of the engine. Bearing in mind it's aluminium, I can't imagine it's took that long to do that sort of damage. A matter of a few revolutions, broken off, and obviously then the damage has been done where the pistons have actually just seized up and broke the con rods, the connecting rods, away from the actual pistons. Well, they're obviously fixing it. We're going to have to remove the motor from the actual frame itself. We're going to drop the oil pan. We're going to remove the crankshaft. We're going to obviously see what sort of damage has been done to the crankshaft itself, see how excessive it is, and we're going to see if we can actually replace these liners, because these pieces here are actually internal sleeves. We can get them out. We can replace the liners, repair the crank, and replace the pistons and build it back up again, and put it obviously back in and get it back on the road. As you can see, we took the first piston out this side, and that would be the second rear piston, which is at the bottom of the oil pan. Obviously all smashed up. And it has taken it away. You've got one connecting rod there, and it has taken it away from the rest of it, and the actual connecting rod has come off the journal of the crankshaft. As you can see, if I move that one about, there should be two connected there in sequence, and the other one is completely missing, which is all in the bottom of the oil pan. Right, now tea time's over. Let's take the rest of the engine apart and we can find out what's actually happening inside the engine block. Can you pass me the tools? We've removed all the bolts now that hold the sump to the bottom of the engine. Now we're just going to take the sump off and obviously see the extent of the damage on the crankshaft journal itself.
Okay, get together.
You can see all the damage that's been done here where the journal was broken, the big end is broken. Damaged it badly, and all the swarf inside here, all the broken up parts. I mean, it's just badly excessive. Broke all that away as well. That piece of casing must have gone to the end, smashed all that off. Looking at the situation, it's not good, but I don't think I'll be going to the extent of a new block because obviously what's happened to it. Right, now here it is. Obviously we've taken the oil pan off. We can see obviously the damage that's been done to the crankshaft, the side of the block casing, the webbing of the crank, the actual oil splashback tray. It's excessive. It's not excessive enough to put a hole in the side of the block, but it has tried obviously quite profusely to get through the side of the engine.
I don't think that's gonna...
Now we've removed the oil pan and we can remove what's left of the bottom piece of the connecting rod. And as you can see, it's smashed the top completely off of it. It's been banging about, and this is the short space of time before the engine's actually given up. Hopefully we might be able to rebuild the crank and rework the crank and some of the engine parts to get the engine back together again working. That's done the crank quite badly. Oh my God, look at that. That is absolutely destroyed that. See that your oil pickup is actually inside the oil pan, the sump. It's actually cast inside it. What a load of engineering for no reason. What's left of all the piston rings, the piston skirt, all where the gudgeon pin goes through. It's just complete. That's one of the small ends from the piston. There's what's left of the other conrod. There's your bearing shells. All the other pieces, small end from the top of the conrod. And that would be the other small end from the conrod. There would be another part of the small end, all completely and utterly destroyed. There's a bit of a ring. Completely destroyed. All under the spray pan. And the swoof that you've got in here is just unreal. I mean, all stuck up the inside of the oil pan. I mean, it's just like broken glass. It's just unreal, completely unreal, the damage that has been done. In a car that's most probably done 150, 200,000 miles, sludged up engine, oil starvation, I would have seen something like this. A car that's done just over 9,500 miles, there's a serious problem. There's a serious problem, and what has done the serious problem, once we look into it a bit further, don't know until we find out what it is, but I mean it's definitely oil starvation for the two back pistons of the engine to seize up and do this much damage when the other 10 are in good condition. It must be something to do with oil delivery. It's got to be to do with oil delivery. It's oil starvation, and even when we drained the oil pan down, there was still 3/4 full of oil, what has not actually been dumped out on the floor. So it wasn't a question, there was no oil in it. It was a question of it must be a design fault for the oil pump itself to not be pumping the oil around the engine adequate enough to obviously starve it. Obviously, if we look at the damage that's been done to all these parts, part of a piston, part of a conrod, other part of the piston head, the gudgeon pins, the other piece of the conrod and the big end, the other conrod, it's just all completely a big end shell. Another part of the piston, it's just completely and utterly destroyed it. Piston ring, and then all them bits. Small end, bearing. Absolutely diabolical, the damage that's been done to that. For 9,500 miles, for a V12 Aston Martin engine supercar, this is the damage that's been done to it. Absolutely diabolical.
This is the stock rod and piston that came out of this Aston Martin. Basically a garden variety Ford piston from either a Ford pickup truck or a Ford Mustang, either a 3-liter V6 or a 4.6-liter Mustang or truck motor. Unbelievable that they fit this in a motor of this caliber. Basically, it's a hypertechnic piston with a powdered rod, breakaway style, non-serviceable. The oiling system for this type of motor is just junk. For a motor of this caliber, of this status, I can't believe that they bit this type of crap inside it. This is the piston we're using. It's a CP racing piston with a Corella rod, H-beam style, one of the finest on the market, used in everything from NASCAR to Top Fuel to drag racing to boat racing. You know, this is a style rod and piston that they should have been in this motor. You know, they should have overbuilt it because, you know, it's rated at almost 500 horsepower. It should have been overbuilt for like 600 or 700 horsepower for your average street use. You know, I can't believe that Aston Martin and the Ford Corporation would build a motor with stock components that come out of your regular passenger car style car for a guy that's paying $200,000 for a car that's got garden variety parts in it. You know, Aston Martin should have spent the money to put this style piston, this style rod, better oiling system in it, and made the customer happy instead of being here in my shop having to be rebuilt after 9,000 miles. It's this wrong. What we are installing is an aluminum alloyed forged racing piston that is 100 grams lighter and 4 times stronger than the garbage that Aston Martin put in this motor. This is what should have been in this motor to begin with. What we have for this piston is it has a lot of extra strength in the webbing inside. We're using an H-beam style rod instead of the I-beam, which has much more superior strength. ARP bolts. The oiling galleries will point oil towards the top of the piston, which should add in cooling and better lubrication. We have gone with just a little bit of a dome to give it a little more compression, to add some horsepower. The oil grooves, the oiling groove, and the ring grooves are much better than the stock style. We're using a Moblie style ring. It's a much superior, stronger ring than what they had in here before.